Greetings, everybody. So today we are going to begin a new unit here in the course. This is a unit that is actually not in the textbook. This is a separate unit that I've created. And we're going to review just basic algebra applications. So we are going to use a little bit of algebra in this unit. And there's three different types of problems that we're going to discuss. And the first one that we're going to talk about today are what I call work together problems, if you want to phrase it that way. So we're going to look at the first four examples here in the notes, okay? So first let's talk about how we can set these up. So the first example tells us that Amanda can mop a warehouse in 10 hours and that Kristen can mop the same warehouse in 8 hours. So the question is asking, if they work together, how long would it take them? So what we want to do is we want to first of all examine how long it would take each person to do the job separately. Well, we know what that is, right? And notice I have a little chart set up here. You'll always want to set up a chart kind of similar. And we want to write down the time it takes for each person, right? Well, if Amanda were working by herself, mopping the warehouse, it would take her 10 hours, right? This is in hours, the time to complete the task. And if Kristen were working by herself, it would take her 8 hours. Now, what we want to figure out is how long does it take them working together. We don't know what that is, so we'll say it will take X amount of hours, okay? Now, you want to represent how much of the job is completed for each person after an hour. Because think about it. If it takes Amanda 10 hours to do the job, then if we're trying to figure out what fraction of the job is completed in just 1 hour, well, for Amanda, that would be 1 out of 10. Okay, because it takes her 1 hour to do, or it takes her 10 hours to do it. So after she's worked 1 hour, she's 1/10 complete with the entire job. With Kristen, hers fraction of the job, since it takes her 8 hours, would be 1/8. After she works for an hour, it would be 1/8. 1/8. So therefore, the time it takes them working together, well, if it takes them X amount of hours working together, if they've worked together for 1 hour, then 1/X amount of the job would be complete, if that were the case. So basically what we have here is we have the rates for each of the individuals, right? We have the rate for how long it would take Amanda. Basically this is the rate that she is working. This is the rate that Kristen is working. And what we can do is we can combine both of their rates and set it equal to the rate of them working together, right? If we take Amanda's rate and add Kristen's rate, then combined, that will give us the rate of them working together. So we're going to solve this kind of an equation. Now, how do we go about solving an equation like this? Well, I'm just going to show you guys the quick way to do it. It's actually pretty simple, okay? What you're going to do is you're going to multiply all your denominators together, and you're going to get what's called the least common denominator. In this case, 10 times 8 times x, and that's 80x. Okay? We call that the LCD, the least common denominator. Now what we're going to do is we're going to take that, and we're going to multiply it by each one of these fractions. Now, notice what's going to happen. The 80x is just going to divide by 10, and 80 divided by 10 is 8, so we're just going to be left with 8x. Here, the 80x is going to divide by 8, and we're just going to be left with 10x. And then here, the x's are going to cancel, so it's just 80 times 1, which is 80. So now notice we have a much simpler equation, and in fact we're almost done. You guys, I hope, remember your algebra. This is real basic. Just add together 8x plus 10x. They are like terms. So we can combine those to get 18x. And then to solve for x, we're almost done. All we have to do is simply divide both sides by 18. So we take 80 and we divide by 18. And what you should get is approximately 4.44 if you use the calculator. Now, the directions say to round it to the nearest hundredth, so that's what we'll do. So it'll take them about 4.44 hours. You would have to figure out how many seconds, 0.44, or I guess minutes, really. and even seconds. You could round it all the way to the nearest second if you really wanted to, but we'll just stick with decimals in terms of hours. Okay. Make sure you do give your answer to the nearest hundredth. Okay. But we are done with that one. Okay. So let's try the second example, setting it up the same way. It says here that it takes Lena 9 hours to dig a 3 meter by 3 meter hole, and Catherine can dig the same hole in 8 hours. So again, if they work together, how long would it take them? So again, we're looking at it in terms of hours. We know it would take Leah 9 hours, and we know it would take Catherine 8 hours, and working together it would take X amount of hours. So therefore, if Leah worked for an hour, 1/9 of the job is completed, so that's her rate of work. If Catherine worked for an hour, 1/8 of the job is completed, so that's her rate of work, and if they worked together, it would be 1/x. Okay? So we're going to set up similar equation just like we did the other two. We're going to take 1/9 plus 1/8, set it equal to 1/x. All right, now it's time to solve. So remember, you get this, we call it the LCD. Again, just multiply all your denominators together. Just take 9 times 8 times x. That is going to be 72x. So we're going to multiply 72x by each fraction here. Okay? And you guys kind of notice what happens. 72 divided by 9 is 8. Notice that's the other denominator. So this one is just going to become 8x. 72 divided by 8 is 9. So this one's going to become 9x. And then here the x's cancel. So if you notice, it's pretty much going to be the same type of setup every time. Notice that basically we're taking the time it takes each of them to complete their terms multiplied by their time working together, and then you set it equal to what it would be if you multiplied the time it took their tasks together, is essentially how this is always going to end up. But this is the correct setup for how to get there. So this is going to be that 17x is equal to 72, and then we'll just divide both sides by 17. And so 72 divided by 17 on the calculator tells me about 4.235, so I'm going to round it to 4.24. So they'll take about 4.24 hours working together, right? Which, notice, the time it takes them working together should be significantly less than if they were if each person worked by themselves, right? And that makes sense. If two people are working together on the same task, the task will get completed in a shorter amount of time than if, each person were just working by themselves. Okay, I want you guys to pause the video here and try number 3 and 4. So pause the video here, set it up just like I did, give 3 and 4 a try. Okay, so let's see how we did. So we have Castle, who can inflate 20 balloons in 14 minutes. And we have, I think Pranav is how you say his name, can do the same task in 15 minutes. So we know working together would just be X amount of time. So now the fraction of the job is in minutes instead of hours, but it's the same setup, right? Castle's rate is 1 out of 14, right? If he worked for 1 minute, 1/14 of the job is done. For Pravav, 1/15 of the job is done after 1 minute. So combined, that would be 1/x. So it's the same type of setup. 1/14 plus 1/15 equals 1/x. Okay, so there's our equation. We now want to find our, again, we call it the LCD. So take 14 times 15 times x, and that's going to be 210x. Okay, I'm running out of room there, but 210x is what we're going to multiply everything by. Oops, x, there we go. Okay, so 210 divided by 14 will just be 15, so this is 15x. 210 divided by 15 is 14x. And here the x's cancel to get 210. And then we combine 15x plus 14x, I believe that is going to be 29x, is equal to 210. And then you want to divide both sides by 29. Okay? So I combine the like terms to get 29x. So take 210 and divide it by 29. And what we get for x is approximately 7.24. Again, make sure you're rounding correctly to the nearest hundredth. So it would take them about 7.24. This time it's minutes if they worked together in blowing up the balloons. Okay, one more. Let's see how you guys did on the last example here. So working alone, it takes Maria 10 hours to oil the lanes in a bowling alley. Scott can do the same job in 9 hours. Okay, so how long would it take them if they worked together? So 10 hours for Maria, 9 hours for Scott. I forgot my column for if they worked together. Let me put that in here. So if they are working together, that would be X amount of hours. That's what we're trying to figure out. For Maria, we know her rate is 1/10, right? If she worked for an hour, 1/10 of the job is done. For Scott, if he worked for an hour, 1/9 of the job is done. Combined, it's 1 over X. So we're going to say that 1 over 10 plus 1 over 9 equals 1 over X. Okay, and now let's get the LCD. Again, just multiply all of your denominators together, and you will get 90x. And now take 90x and multiply them by every term here. So 90x divided by 10 is 9x. 90x divided by 9 is 10x. And the x's cancel, it equals 90. So 19x equals 90. So now, of course, we just have to divide by the 19. And when I do that, I get approximately 4.74 if I round it again to the nearest hundredth. It says 4.736 on the calculator. Again, round it correctly to the nearest hundred. So that's how many hours it would take if they were working together. Okay, so there should have also been a homework worksheet handed out to you guys. It says Algebra Applications Homework. You guys want to work problems, I believe it's numbers 1 through 6, are all the same type of examples. So work out numbers 1 through 6 for the time we have left in class. And then tomorrow we're going to look at a new lesson. Save all of your work here. Eventually at the end of the week, there'll be a Google form for all the problems that we're going to work on this week. So just save your worksheets. Okay, save your answers, and like I said, by the end of the week, there'll be a Google form for you, okay? But for now, go ahead and begin working on this, and just let me know if you have any questions, and I'll see you guys here in the next video. Thank you very much.